Welcome to the Nordic Venture Show, your speed date with the hottest Nordic innovations and ventures. In this episode, our venture date is with Specim, Hyperspectral Imaging.
Welcome to another deep dive, and today we're going to try to take a look at hyperspectral imaging.
All right.
So, it sounds a little bit out there, a little bit kind of futuristic, but I think you'll see as we get into it that it's actually being used in a lot of really interesting ways already.
Yeah, I think it's I had never really heard of it before I started researching for this, but it's a really cool technology for sure.
So you have some great sources for this.
Yeah.
You have some stuff directly from Specim, which is a global leader in hyperspectral imaging technology.
Yeah.
And so through their stuff and through some other sources, we're going to kind of hopefully come away with a clear picture of what this technology is, who Specim is, and why it all matters.
Okay.
So we have company information, some news and blog posts, even some explanations from Specim's own website about how the technology works.
Sounds good.
So I think a good place to start with this is with kind of the fundamental question. What is hyperspectral data imaging?
Well, in essence, what hyperspectral imaging is a way to identify and even sort different materials based on their chemical makeup.
Okay.
And what's really incredible is that it can do this even when those materials look virtually identical to the naked eye.
So like you could have two apples
that
look exactly the same, like two green apples.
Yeah.
But hyperspectral imaging can look beyond what our eyes can see and tell us about the subtle differences in their chemical makeup.
Precisely. And the way it does that is by analyzing how those apples, or any material for that matter, reflect light, but not just in the typical red, green, and blue that we see with our eyes.
Okay.
It analyzes a much broader range of colors, creating what is known as a spectral signature, which is unique to each material, almost like a fingerprint.
So like one apple might be a little bit riper than the other one.
Exactly. Or it could even reveal things like bruising that you wouldn't be able to see just by looking at it.
Oh.
And the reason it can do that is because every single material interacts with light in a slightly different way, absorbing some wavelengths and reflecting others. And hyperspectral imaging captures this reflected light in hundreds or even thousands of very narrow bands of color.
So like way more than our eyes can see.
Way more. It's like having hundreds of tiny buckets collecting different shades of light compared to the three wider buckets that our eyes use.
Okay.
And this abundance of data, this rich spectral information, is what makes that precise material identification possible.
So it's like getting a much more detailed picture
Exactly.
of the light that's being reflected off of things.
Yes, a much more complete picture.
Yeah, cool. So to kind of dig into this a little bit more, I think it's helpful to talk about Specim, which is one of the companies that's really driving this technology.
Right.
So who are they and what's their story?
So Specim, formerly known as Spectral Imaging Ltd, is really one of the leading global suppliers in this field.
Okay.
And they've been around for a while, since 1995. So they have quite a bit of experience. And in 2020, they became part of the Konica Minolta group, which really expanded their reach globally.
So are they like headquartered somewhere specific?
Yeah, their headquarters are in Oulu, Finland, which sounds very high tech.
It does, yeah.
But they also have offices in the U.S., China, Germany, and Spain.
Wow.
And a pretty large network of distributors all around the world.
Okay.
So no matter where you are, you can pretty much find Specim technology and support.
So they have a pretty big global reach.
Yes, they do.
And in terms of their products, what do they actually make?
They have a pretty comprehensive range of hyperspectral cameras.
Okay.
And these cameras cover a very wide spectrum of light, from the visible range all the way to near infrared and even thermal wavelength.
Wow.
And of course, they also offer the software and all the necessary accessories that go with these cameras.
Okay, so they're not just providing the hardware, they're providing a whole system around it.
Exactly. It's a complete solution.
So who are their customers then?
Their customers are quite diverse. They work with companies that build and integrate these cameras into larger industrial systems, as well as with research organizations all over the world who use this technology for a variety of applications.
Now, on their website, they describe themselves as a trusted partner known for robust and cost-efficient products and superb customer support, which, of course, a lot of companies say.
Of course.
What's the evidence that they actually live up to that?
Well, one thing that stands out is their core strategy, which they call Spectral Imaging Made Easy. And this really emphasizes their focus on making this complex technology accessible and usable for a wide range of applications and users.
Okay.
They also talk a lot about scalability, meaning that their technology can be adapted to different needs and production levels. And importantly, they highlight that their development is really driven by customer needs.
Yeah.
They want to provide fast, accurate information that ultimately leads to a good return on investment, or ROI.
So they're not just focused on the technology for technology's sake. They're focused on solving real problems.
Precisely. And I think that focus on practicality and customer value likely contributes to their reputation as a trusted partner.
Yeah, that makes sense. And they also talk about their commitment to long-term partnerships.
Right.
What does that mean in the context of this kind of specialized field?
Well, it seems to go beyond just selling a product.
Okay.
They emphasize their in-house expertise across multiple areas, including optics, electronics, software, and mechanics.
Okay.
And this allows them to really understand and address the complex challenges that often come with implementing hyperspectral imaging in different settings. They also highlight their capacity for scaling up production and providing maintenance, calibration, and repair services.
Okay.
Which shows their commitment to supporting customers throughout the entire life cycle of their systems.
So it's not just like a one-time sale. They're in it for the long haul.
Exactly. That's the idea.
So now we have a better sense of who Specim is. But let's zoom back out a little bit and talk about why hyperspectral imaging as a technology should matter to people in general.
Okay.
What are the main benefits and what kind of problems can it help solve?
Well, as we touched upon earlier, one of the key advantages is that it's non-destructive.
Okay.
Meaning you can analyze a material without altering or damaging it in any way.
Right.
And it's also incredibly accurate and can deliver results very quickly. And Specim actually provides some pretty compelling examples of how versatile this technology can be.
Oh.
They mention its use inside a pharaoh's tomb.
Really?
Yeah. Imagine analyzing ancient pigments and materials without having to disturb them in any way.
Wow.
They also talk about using it under ice for environmental research and even for surveying an ancient Roman city.
So like archaeology.
Exactly. It could potentially reveal buried structures or tell us about the composition of ancient materials.
That's amazing.
Yeah, and beyond these really visually striking examples, they also emphasize its widespread use in research and across many different industries for essentially identifying, locating, sorting, and quantifying materials that are simply invisible to the naked eye.
So it's like giving us superpowers.
It is. It's like being able to see things that were previously hidden.
Cool. So what are some of the specific benefits of being able to see those things?
Well, Specim points out that this technology can lead to improved processes, better quality control, and a significant reduction in waste across various applications.
So give me an example.
Sure. Let's say you're in food production.
Okay.
If you can precisely identify and remove even tiny contaminants from something like coffee beans,
Okay.
that obviously has a huge impact on the quality and safety of the final product.
Makes sense.
And ultimately, that translates into cost savings and a higher quality product for consumers.
Okay, so it's not just about seeing things. It's about making things better, more efficient, safer.
Exactly.
Yeah.
It's about using that information to make informed decisions and improvements.
Cool. So let's dig a little deeper into the technology itself. We talked about spectral signatures earlier. What are they in a bit more detail, and how do they actually provide this valuable information?
So remember that every material reflects light in its own unique way.
Right.
A spectral signature is essentially a detailed graph that shows you how much of each wavelength of light is reflected by a given material. It's kind of like a barcode, but instead of just identifying a product, it identifies the specific chemical and physical properties of that material.
Right.
And by comparing the spectral signature of an unknown sample to a library of known signatures, you can very precisely determine what that sample is made of.
Oh, so it's like a fingerprint database, but for materials.
Exactly. It's like having a vast library of material fingerprints at your disposal.
That's cool. Now, in their technology section, they mention line scan push broom cameras.
Yes.
Could you give us like a super simple explanation of how those work?
So imagine a regular camera that takes a whole picture at once.
Yeah.
A line scan camera, on the other hand, captures just one line of spectral information at a time. And then as the camera or the object being scanned moves, these lines are assembled into a complete hyperspectral image.
Okay, so it's like scanning a document.
It's very similar to that.
Okay.
And this approach is really effective for applications where you have moving objects, like on a conveyor belt in a factory, or when you're capturing images from an aircraft or a satellite as it moves over the ground.
Okay.
It allows you to gather consistent data across the entire moving object or area.
Cool.
Yeah.
Now they have this technical note that talks about effective pixels and spot size in industrial applications.
Yeah.
And they suggest that sometimes less can be more, which seems a little counterintuitive.
Yeah.
What's the thinking there?
Well, what's interesting here is that in some industrial settings, having super high spatial resolution, meaning really tiny pixels, might not actually be necessary and could even be a disadvantage.
Absolutely.
Because all that extra detail might not provide any useful information for the specific task at hand.
Okay.
And it can actually make the data more complex to process and potentially harder to identify the key features you're looking for.
So it's like if you're looking for a needle in a haystack,
Right.
you don't necessarily want to examine every single piece of hay in microscopic detail.
Exactly. It's about finding the right level of detail for the task.
Okay.
Not necessarily the most detail.
And Specim also seems to be focused on making it easier to actually work with all this data.
Yes.
They recently presented Spectral Insight 1.4, which is their latest hyperspectral image analysis software.
Yeah.
So what's significant about that for someone who's using this technology?
Well, developing powerful and intuitive analysis software is absolutely crucial.
Okay.
Because all that rich spectral data that these cameras collect needs to be processed and interpreted to be truly useful.
Okay.
And a new version of their software likely means that they've made improvements to make it easier to visualize, classify, and ultimately understand the information contained within those images.
Okay, so it's not just about the cameras themselves. It's also about having the tools to actually make sense of the data.
Exactly. You need both to make the technology truly powerful and accessible.
So let's talk about some real-world examples of how this actually works.
Okay.
One of the examples that Specim mentions is using hyperspectral imaging to detect contaminants in coffee beans.
Yes.
So how does this technology actually help with a problem like that?
So imperfect or contaminated coffee beans can really impact the quality and even the safety of the coffee we drink.
Right.
And what hyperspectral imaging systems can do is analyze individual coffee beans as they're moving along a processing line.
Okay.
And because different types of defects or contaminants, things like mold or foreign objects or even beans that are damaged inside, will each have their own unique spectral signature. The system can automatically identify and remove those undesirable beans.
So the beans might look the same to us.
Exactly.
But the camera can see that they're actually different.
Precisely.
And sort them accordingly.
Right.
That's so cool. Now, they also have this portable hyperspectral camera called Specim IQ.
Yes.
Tell me about that.
So the Specim IQ is really designed for taking hyperspectral measurements and doing analysis out in the field. It's a self-contained device. It has a touchscreen, built-in data processing software, and its own data storage.
So it's like a little mini lab.
It is, and what makes it really user-friendly is that it works very much like a regular camera.
Okay.
You just point it at what you want to analyze, provide some illumination, adjust the focus, and take a spectral snapshot.
Okay.
And you can see the results directly on the device.
So where would this kind of portability be especially useful?
Well, Specim highlights a whole bunch of potential applications.
Okay.
In vegetation research, you could use it to quickly assess plant health in the field.
Okay.
For food analysis, you could use it to check the quality of produce right there in the supply chain. It even has applications in areas like crime scene investigation.
Really?
Yeah, for analyzing trace evidence on site in art analysis, for identifying pigments in historical artifacts without having to move them, and even in the health sector for potential non-invasive diagnostic applications.
So it has applications across a lot of different areas.
A really wide range.
So if you're using this camera, how do you know how to set it up correctly?
Well, Specim provides a field of view, FOV, and working distance calculator specifically for the Specim IQ. And this tool helps you determine the exact area you'll be imaging and the precise distance you need to be from the target to capture that. They also have a glossary of terms that are important to understand.
Like what?
Well, things like working distance, which is simply the distance between the camera lens and the object.
You're imaging a cross-track FOV, and a long-track FOV, which define the width and height of the image you're capturing.
Okay.
Depth of field, which is the range of distances that will be in focus. And sampling pixel size, which refers to the level of detail in your image.
Okay.
So all of this practical guidance really helps users set up the camera correctly and make sure they're getting the most accurate data possible. So they're really trying to make it user-friendly.
Yeah. It seems like ease of use is a big priority for them.
What about Specim's role in the industry as a whole?
They're definitely not just operating behind the scenes.
Right.
They actively participate in major industry events like the Automate Show in Detroit, Laser World of Fonts, Photonics China, and Photonics West.
Okay.
And these are really key platforms for showcasing their technology and connecting with potential customers and collaborators.
So they're really engaged with the wider industry.
Very much so.
Now it also looks like they're kind of moving into more of a leadership role.
Yeah, Tapio Kolonen, who's Specim's CEO, recently joined the Photonics Finland board, which suggests that his expertise and the company's vision are being recognized and will likely contribute to shaping the future of photonics and hyperspectral imaging.
So what about this hyperspectral imaging standardization that's mentioned?
Well, as with any technology, as it matures, establishing industry standards becomes really important.
Why is that?
Well, it promotes interoperability between different systems.
Okay.
Ensures that data can be compared in a consistent way. And ultimately, it helps the whole market grow and become more reliable and trustworthy.
Okay.
And the fact that hyperspectral imaging standardization is being discussed is a good sign.
Yeah.
It shows that the field is moving towards greater maturity and broader adoption.
So we've covered a lot of ground here.
We have.
What are the main takeaways that people should remember from this deep dive?
Well, I think the key takeaway is that hyperspectral imaging, which companies like Specim are really pioneering, offers a really powerful way to see the invisible by analyzing those unique spectral signatures that we talked about.
Right.
And this capability has so many potential applications in so many different fields.
Yeah, from the coffee we drink to ancient artifacts to who knows what else.
Exactly.
It seems like Specim in particular is really committed to making this technology more accessible and user-friendly.
Yeah, their spectral imaging made easy philosophy really comes through.
Yeah, and those portable cameras like the Specim IQ are a great example of that.
They're really trying to bridge that gap between the complex science and the practical applications.
Yeah, so as we wrap up, here's a final thought for everyone listening. Given all the amazing things that hyperspectral imaging can already reveal, what other aspects of our world could benefit from this kind of detailed analysis?
That's a great question.
What new applications might emerge as this technology becomes even more refined and more widely available?
Yeah, it's really exciting to think about all the possibilities.
Thanks for joining us for this deep dive.
Thanks for having me.
And we'll see you next time.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.